Alright, hello everyone. I hope everybody's doing alright. Today I want to talk about quadratic equations. A quadratic equation, we've talked a little bit about quadratics in general. A quadratic equation is when you have something in the form ax squared plus bx plus c is equal to 0. Now if it's not written like this, if it's a quadratic equation, you can always make it like that. So suppose you have a number on the right hand side, you can always subtract it on both sides to get it equal to 0. So our goal is to be able to solve this. So to solve, the very first thing you should do is factor it. If you can. If you can factor it, factor it. If you can't factor it, then you can't. So, well, we'll move on to the next thing. So for instance, if you had x squared plus 7x plus 12 equals 0, and we've done this, we can do this x plus 3 times x plus 4 is equal to 0. And so you set, because these two things multiply to make 0, one of them has to be 0. So that means either x plus 3 is equal to 0 or x plus 4 is equal to 0. And if you solve each of these, you get x equal to negative 3 and x equal to negative 4. So that would be your solution set for this quadratic equation. So if you can factor it, factor it. But what if you can't factor it? One of the things you could try to do is you could check to see if it's a perfect square. Now what I'm about to do is actually not a way that you would do it. And so something I'm going to show you is going to actually be factorable. But, well, let's say we had x squared plus 6x plus 9. Let's make it equal to 4. So, first of all, if I subtracted 4 from both sides and set it equal to 0, it would be x squared plus 6x plus 5 equals 0. That's factorable. You could do it. No problem. But let's see the fact that this is a perfect square on the left-hand side. So since this is a perfect square, this is x plus 3 times x plus 3, or x plus 3 squared. And using the principle of square roots, this tells me that I've got two solutions. Either x plus 3 is equal to the square root of 4, or x plus 3 is equal to the negative square root of 4. And since the square root of 4 is 2, I get two equations. X plus 3 is equal to 2, or x plus 3 is equal to negative 2. So in this case, I get x is equal to negative 1, or x is equal to negative 5. Now again, I would actually get this out of factoring, but here I found another way to solve a quadratic equation using this idea of perfect squares. So when you're solving, you're not typically going to use perfect square because you're not usually going to be given something so beautifully nice. On the other hand, you can always force a square. You can always do what's called complete the square. So I want to talk a little bit about completing the square. Completing the square basically goes something like this. So suppose that I had x squared plus 4x plus 9 is equal to 0. So you go to try to factor it. What are the factors of 9 that add to 4? There is no such thing. So what you do instead is you say, okay, wait. I have x squared plus 4x plus 9. Let's just move that 9 over because that's a problem. Do x squared plus 4x is equal to negative 9. And the point is this. Because I have x squared plus 4x, it almost feels like I must have had x plus 2 times x plus 2. If it was a perfect square, it feels like it should have been x plus 2 times x plus 2. But x plus 2 is x squared plus 2x plus 2x plus 4. And that gives me x squared plus 4x plus 4. So it almost looks like a perfect square. It almost looks like an x plus 2 squared, but it's missing the 4. Since it's missing the 4, I'm going to complete it by making that 4 add in. Now, because I have an equal sign, I've got to do it to both sides. So plus 4 plus 4. So I get x squared plus 4x plus 4 is equal to negative 5. Now this is a complete perfect square, so I get x plus 2 squared is equal to negative 5. And now I can use the principle of square roots to say that x plus 2 is equal to the square root of negative 5, or x plus 2 is equal to the negative square root of negative 5. So x plus 2 is equal to 5 square root of 5i, or x plus 2 is equal to the negative square root of 5i, because the square root of negative 5 is square root of 5i. So x is equal to negative 2 plus root 5i, or x is equal to negative 2 minus root 5i when you solve both of these. So even though we couldn't factor it, we could actually solve it out. And that's called completing the square. Now if you're wondering why it's called completing the square, notice that I've got x squared plus 4x. So x squared is almost like a box, an x by x box. And 4x is almost like a rectangle, a 4 by x rectangle. Now, if I cut that rectangle in half, then I could put the rectangle, one half of the rectangle on the top, one half of the rectangle on the side. So here's what I'm getting. I get an x by x box, and then I have a 4 by x right here, and I could put a 2 by x right here, the half, and a 2 by x right here. So I cut this in half, I put half here and half there. So this half went here, and this half went there. What's the missing piece right here? Well, it's a square, and the square's length must be the same as this length, so it must be 2. And the square's width must be the same as this width, so it must be 2. So the area is 4. And that's why we added 4. Now where does that 4 come from? It comes from taking half of the number in front of x, because I cut that rectangle in half. So if I cut it in half, I take half of that, and then I squared it. So, and if I square it, then I add it in, and that actually completes the square, and it allows me to work this out. What if I had something in front of the x squared? So suppose I need to complete the square again. We can play the same game. So suppose that I have something like 2x squared plus 4x plus 9 is equal to 0. So the first thing I do is I move the 9 over because it's bothering me. And I get 2x squared plus 4x is equal to negative 9. The second thing is, when I had an x by x, it made sense, but what do I do with this 2x? Well, if you don't like the 2, factor it out. So we're going to factor it out. So we subtracted c, and then factor out a. And we got 2 times the quantity x squared plus 2x is equal to negative 9. Now there's 2 different ways to kind of handle this. One way is to divide by the 2. The other way is to just complete the square on the inside. Me personally, I like to complete the square on the inside. So that's the way I'm going to do it. It's going to be helpful later on when we actually go to graph. So we're going to complete the square. But there is an issue when you complete the square like this, and that's because if I take the half of the 2, and I square it, so remember that's like that rectangle piece, I get 1 squared, which is 1. So I need to add 1 to the inside. So now I have 2 times the quantity x squared plus 2x plus 1, and that is a perfect square, so it works, is equal to negative 9. Now here's the problem. I've got an equation. So there's an equal sign, and I just added 1 to the left-hand side. So I've got to add 1 to the right-hand side, right? Not so fast. I added 1 to the left-hand side, but I added it inside a parenthesis. If I was to distribute this out, you'll see that I did not really add 1, I added 2, because of the 2 on the outside of here. So what you've got to do to make this work out is you have to look at the a that you factored out, look at the thing that you just added to complete the square, and then add that to both sides. So technically I added a 2, so I'm also going to add 2 over here. Now that it's cleaned up, I've got 2 times the quantity x plus 1 squared is equal to negative 9 plus 2, which is negative 7. Now I can divide by 2 on both sides. So I get x plus 1 squared is equal to negative 7 halves. And now I can use the principal of square roots to say that x plus 1 is equal to the negative square root of negative 7 halves, or x plus 1 is equal to the square root of that, or the negative square root of that. And then I can finish solving. Now you could do this on, you can actually just finish solving by subtracting 1. So this is x is equal to negative 1 plus root 7 halves I, or x is equal to negative 1 minus root 7 halves I. So that's completing the square. In general, people